In this video, we're going to talk about quartiles. In the past, we talked about median, and we said that median is the number in the middle. When we have to line up data from smallest to the largest value, and then find the value that's in the middle. So in this case, we have 6 values. So our middle falls in between value number 3 and value number 4. And we learned that in this case, we have to average those out. So we have 65 plus 67 divided by 2, and that will give us 66. And this is our median. And we also said that the median divides our data set into the bottom 50% and the top 50%. So 50% of our data lies directly below the median, and 50% of our data values are above the median. Now, these two portions could be divided further. So the bottom 50%, we could find the median of the bottom 50%, and that's the value in the middle. In this case, it's going to be 65. 65 is our middle value of the bottom 50%, and this is called a quartile 1 value. Quartile 1 value. And the quartile one value also divides the data set into bottom 25%, and then the rest would be 25 and 50, so that gives us 75% of the values. Now if we divide the top half values, again, find the median for the top half, that's going to be, in our case, it's 67, and that value is called quartile 3 value. And the median, of course, is our quartile 2. Median or quartile 2, same thing. All right, so that's how we can divide our data set further into 4 parts. Now, next, we're going to talk about percentile. We can actually find the value that separates any percentage. So in this case, we have 25% below 65, we have 50% below 66, and 75% below 67. But what if we were asked to find the value that separates, let's say, 20% on the bottom from the 80% above that value? That would be called percentile. Let's take a look at percentiles and how to find them. In general, the P percentile is a value that separates the bottom percentage that's given from the remaining values on the top of the data. So for example, it says here, indicate P with a subscript 35 on the graph below. Okay, so let's say we have a normal data set like this one. Where would be P35? Well, according to this definition, P35 is the value that separates the 35% of the values on the bottom to the left of it. So here's our scale that gives us a percentile, right? Notice that it's always from left to right. We have 0% on the left and 100% on the top, on the right. So left is the bottom, right is the top. So if it's 35% on the bottoms, that means that we're going to start from the left and we're going to shade until we reach 35%. So 35% is right here. So that's this value that would be here. would be our 35th percentile. Okay, we don't actually have a data that we can look at, so we don't know what that value is going to be, but we can find the location, look at how your percentiles are actually tied in with z-scores. Okay, so when 50% coincides with a 0 on a z-score, right? And then the 5% almost coincides with a negative 2%, with a negative 2 on a z-scale. Now 95% coincides with positive 2 on a z-scale. So I just want you to keep in mind that the percentiles and the z-scores are connected. Okay, the z-scores are tied to the center of the data, which is 0, and which coincides with 50%. Okay, so let's take a look at how we could find actual values if we have actual data. So it says each quartile corresponds, so this is about quartiles. Each quartile corresponds to a particular percentile. So quartile 1 corresponds to P25. So as we mentioned before, 25% of the data lies below the value, that's Q1, and separates the bottom 25%. Okay, from the top 75. Quartile 3 corresponds to 75%. P was the subscript 75 and separates the bottom 75% from the top 25%. Now, how do you find those percentiles? What's the procedure? Here's the percentile locator formula. So to find the location of that value, you're gonna use this formula. It's K divided by 100 times N, where K is the percentile. So for example, if we wanted to find the 35th percentile, then K would be 35. And then N is the size of our data. Now, note, if L, well, let's start here. If L is not a whole number, round up to the nearest integer to find the location of the value for the percentile. That's pretty straightforward. If L is a whole number, then the percentile is the mean of that value located at L and the next one up. Okay, let's take a look at some examples. Okay, so here we asked to find the 35th percentile for this data set. So our first step would be to arrange this data set from smallest to largest. So I'm done with that. Then I need to find the location of my 35th percentile. So K here equals 35. I'm gonna substitute it, and N, by the way, equals 14. I have a total of 14 values. So it's gonna be 35 divided by 100. So basically convert my percentile and multiplied by 14. Okay, so basically convert my percentile to decimal form. So I have 0.35 times 14. Let's do that. 0.35. Sorry, guys, I'm not too many thoughts going through my head. Okay, 0.35 times 14. That's 4.9. Okay, so 4.9. We were told to round up if our number is not a whole number, so it's almost 5. So that means that that is a locator. So that means that value number 5 is our 35th percentile. So we start counting 1, 2, 3, 4, 5. Right here, that's 64. So we're gonna say the 35th percentile is 64. What that means is the 35% of the values lie below that value, and the rest, 85, is going to be above that value. So that's how you find the value that corresponds to the given percentile.